Hello. In the last video we spoke about the nucleus of an atom, the building block of all matter in the universe. In this video we are gonna discuss something just as important as the nucleus of the atom. The law of charges. To understand atoms, it is necessary first to understand two basic laws of physics. First, the law of charges. And it states that opposite charges attract and like charges repel. The second law to the understanding of atoms is the law of centrifugal force. It states that a spinning object will pull away from its center point, and that the faster it spins, the greater the centrifugal force becomes. Valence electrons. The outer shell of an atom is known as the valence shell. Any electrons located in the outer shell of an atom are known as valence electrons. It is the valence electrons that are of primary concern in the study of electricity, because it is these electrons that explain much of the electrical theory. A conductor, for instance, is generally made from a material that contains one or two valence electrons. Atoms with one or two valence electrons are unstable and can be easily made to give up these electrons with little effort. Conductors are materials that allow electrons to flow through them with little resistance. When an atom has only one or two valence electrons, these electrons are loosely held by the atom and easily given up for current flow. Materials such as silver, copper, and gold all contain one valence electron and are excellent conductors of electricity. Silver is the best natural conductor of electricity, followed by copper and gold, and last but not least aluminum. Although it is known that atoms containing few valence electrons are the best conductors, it is not entirely known how or why some of these materials are better conductors than others. Copper, gold, platinum, and silver all contain only one valence electron. Silver, however, will conduct electricity more easily than any of the other materials. Aluminum, which contains three valence electrons, is the better conductor than platinum, which contains only one valence electron. Electron flow. Electrical current is the flow of electrons. It is produced when an electron from one atom knocks electrons of another atom out of orbit. When an atom contains only one valence electron, that electron is easily given up when struck by another electron. The striking electron gives its energy to the electron being struck. The striking electron settles into orbit around the atom, and the electron that was struck moves off to strike another electron. The same effect can be seen in the game of pool. If the moving cue ball strikes a stationary ball exactly right, then the energy of the cue ball is transferred to the stationary ball. Then the stationary ball moves off with most of the cue ball's energy. This moving flow of electrons sometimes can be observed in the form of heat. And that is why proper sizing of electrical conductors is critical, and it is something we will discuss more in details in future videos. Insulators. Materials containing 7 or 8 valence electrons are known as insulators. Insulators are materials that resist the flow of electricity. When the valence shell of an atom is full or almost full, the electrons are held tightly and are not given up easily. Some good examples of insulators materials are rubber, plastic, glass, and wood. Semiconductors. Semiconductors materials that are neither good conductors nor good insulators. They contain 4 valence electrons and are characterized by the fact that as they are heated, their resistance decreases. Heat has the opposite effect on conductors, whose resistance increases with an increase of temperature. Semiconductors have become extremely important in the electrical industry since the invention of the transistor in 1947. All solid-state devices such as diodes, transistors, and integrated circuits are made from combinations of semiconductors materials. The two most common materials used in the production of electronic components are silicon and germanium. Of the two, silicon is used more often because of its ability to withstand heat. Before any pure semiconductor can be used to construct an electronic device, it must be mixed or doped with an impurity. So far in this video we have talked about the flow of electricity.